Hello, this is Michael Goldfarb from Side Effects Software. Welcome to this second series of rigging in Houdini. In this series, we'll start with an overview of the rig that we built in our first series, including some changes to its UI, some of its scripts, and the updated proxy geometry. Then we'll look at capturing geometry in Houdini in general, and how it's accomplished. We'll look at bones and their capture parameters, the capture and deform regions, capture pose and capture frame and how they differ. We'll look at aligning the capture pose. Then we'll look at the capture types available, including region, proximity, biharmonic, and wire. Then we'll look at editing capture attributes using Edit Capture Regions tool, the Edit Capture Weights tool, the Paint Capture Layer tool, and the Capture Correct tool. And then we'll capture and work on our rig that we built last time. We'll be using biharmonic capture. We'll look at how to adjust the weights using the various tools. We'll look at mirroring our capture. We'll talk about attribute transfer. We'll look at level of details and maintaining our capture attributes. And then general geometry management. I hope you find this interesting and have fun. Something that might seem obvious, but is still worth pointing out, is that if your character or asset doesn't require capturing and deforming, then don't do it. This little character, which can be found in our characters shelf, is just a simple little cartoon robot. But he's fully animatable. He's got all his little bits that move around. He's got bones, and those bones have geometry that are parented to those bones. And he's a complete working character. And there's no deformation going on here at all, and therefore no capture. So again, it sounds like an obvious thing, but it is worth pointing out that if your character or even some small piece of your character doesn't require deformation, then don't do it. Your performance will improve and it's less work. So just keep that in mind. Let's do a quick review of the asset that we built in the last series. For those of you who followed that series, you'll be very familiar with this soldier character. For those who haven't seen the previous series, don't worry, we're not going to be going through any of the rigging aspects here. We're going to be dealing with capturing. So this quick overview will tell you the kind of character that we're using and the kinds of things that he can do. So he's just a standard rigged character. He's got FK and IK for his arms and legs. He's got proxy geometry currently. And if I move his arm, you can see that it's just simple geometry. There's no deformation happening here. This is just parenting. And then some of the differences from the last series, you'll notice that I have new proxy geometry, which is actually the deform geometry that we're going to use. The previous proxy geometry was just sort of an export from the modeling, and it wasn't really suitable for deformation. But this is a better piece of geometry. So he's got a nice flow in his forearm, so that when we twist that around, it'll twist straight. So it starts a little bit curved, but when he twists it out, it'll twist straight, and that'll help our deformations. So to do that, all I did was, if we go into the asset, you'll remember that inside each of our proxy geometries, we had injected into the asset itself each piece of geometry, and then read that back into our scene using a file node, then fed that into a pose scope node to give us that invisible rigs ability. But we had left this object merge alone. We just left it here sort of on its own. The reason I did that is because I knew that I was going to be updating my proxy geometry. And so I can reuse this object merge in each of these proxy geometries. So let's see if I've left it in here. Yeah, so now I've removed all of those groups that we had made because I don't need them anymore. But all I really did to recreate this new proxy geometry was bring in the new model, remake all of the groups, and then these object merges would read those groups. And so now I have just the proxy for the pelvis, just the proxy for the chest, etc. So then I just used the scripts that we made last time to re-inject this geometry, and then this file node still works into the pose scope, and we're back to where we were at the end of last series. So that's the proxy geometry. The other change that I made was just to the interface. I cleaned things up a little bit, rearranged some things, and then on this master tab, I changed some of these drop downs that we had. I changed them into what are called button strips. So these are kind of quick buttons. So you can see I'm turning this master control off and on. My geo display is simply one button rather than a drop down. Proxy, bones on, bones off, controls off, controls on. And these are an interesting UI. They're a little bit different than this drop down menu in the way that they work. And so you have to do something slightly different in the script. And we can go through that really quickly. So here the geo display, I'm still using a menu, off, proxy, and deform, but the menu type is set to toggle field plus multiple selection menu. So that's slightly different. In the parameter itself, I'm still using this callback to the gDisplayAll and sending it the KW arguments. But in the script, that's gDisplayAll here. So I'm passing in KW arguments. But in order to figure out what these mean, because they aren't simply 0, 1, 2 that I can use directly, I have to interpret this, what's called a bitwise operator. So in order to do that, I wrote a little function called button strip, and I'm passing KW args into that function and then reading that value and putting it into value. Then I'm using that value to set all the other display options. So this button strip down here, I'm importing the math module because I'm going to use it to interpret the bit field. And then, so I'm sending the parm that presses this button, getting its bit field by evaluating the parm, then interpreting bit field using math.log bit field, putting that into the selected index. So that's essentially our 0, 1, 2 number. And then as a way of creating this kind of one-shot button action, instead of this sort of toggle, I'm setting the parm back to 0. So really when I click off, it is, turning this on. It's highlighting it and it's staying there. But I don't want that. I want it to turn off again as soon as I release the mouse. So that's what this is doing. It's setting it back to 0 or off. And then I'm returning that selected index back up here, putting that into the variable value that I'm using to drive the rest of the parameters. So that's kind of an interesting UI that you can use. You just have to remember that these button strips are slightly different and they have to be handled slightly differently. I can turn my proxy back on. So that's the update on the rig itself. And now we're going to capture this geometry. As we saw in the earlier series, we can select and transform our geometry just here at the object level. And we can also parent this geometry to other objects like bones or nulls. But in a typical character workflow, or anything outside of mechanical rigs, you'll want to deform the actual geometry itself, not simply transform the object. So how do we do that? Well, in Houdini, we use a process called capture geometry. You might hear it being called skinning or enveloping or a bunch of other names, but in Houdini it's called capture geometry. And to do it, we use the capture geometry tool. So in the viewport, I can just tab and start typing capture geometry, and it's this capture geometry tool. So for this very simple example, I'm not going to use the defaults. We'll go through all of these options later. But for now, I'm just going to choose regions as my type, method I'm going to leave at append, and root of skeleton I'm going to change to individual bones. I should actually show you the bone that's in there. Let's turn that on. Turn this off. So I'm prompted down at the status bar to select the geometry objects to capture and then press enter to continue. So I can select my geometry. I can hit enter, or I often use the right-click option, accept selection. And now I'm prompted to select the bones to capture with. And again, in a crowded network, I like to use the network view itself, but you can use the viewport. So I'll select the bone, and again, I'll right-click and accept that selection. So right away, a couple of things happen. One, most of the tools go away. In the status bar, we can see that one object captured has been prompted to us. And then our geometry has this sort of red coloring. And our geometry object itself has a little word balloon. And that means that there's a comment on this geometry. So in the viewport, I'm going to hit escape to leave the capture geometry tool. You can see that red goes away. And I'm going to have a look at the comment on our geometry by middle clicking. And I can see that transform parameters are locked because the geometry has been captured by bones. So Houdini is enforcing this idea that we're no longer going to be transforming our geometry object. Rather, we're going to be deforming the geometry inside. So that's why it automatically locks these parameters. So if we dive back inside, we can see we have our grid, and then we have two new nodes. One of them is bone capture, and the other one is bone deform. All of the capture tool modes, whether it's region capture, proximity, or biharmonic, they'll all create a deform SOP for you. The difference will be the stuff in the middle. And we'll go through those individually later. But very quickly, bone capture is a pretty simple SOP. It takes a hierarchy or a series of extra regions, and these regions are located inside of the bone objects. And then it creates some attributes. In this case, a bone capture attribute, a pcapped frame attribute, so p capture frame, and pcap skell root, or capture skeleton root. So if we go to our geometry spreadsheet and we look at the points, we can see that we have this bone capture region, and it has two values associated with it. One of them is the region itself, and the other one is the weight. And in this case, we have, if we go back to our, let's just turn on color by capture region. You can see that we have this region, which we're getting from the bone, and then some of these points have been colored red, and that red color is coming from the bone, which is a red color. And then some of these points are still white, and if we look at our bone capture SOP, we can see we're choosing to visualize the capture by capture region, and then zero weight point color is white. So this is a way we can tell that these points have been captured and these points have not. So we'll go back to our spreadsheet and we can see that all of the points have the bone capture attribute, but only some of them have a value. So these are the ones that have been captured. And then the weight is to tell the deform SOP how much of each region should influence these points. In this case, we just have the one region, so the weighting is going to be 1 or 100%. But we might have 2 or 10 or 200 bones capturing this single point. And so each of those bone regions will have a weight that will add up to 1 because we're normalizing our weights here. And normalizing is really handy if you're painting later on. You'll always want to have normalize on. So the other attributes, other than this point attribute of bone capture, is in our details tab, and pcap frame and pcap skell root. Pcap frame is a kind of a holdover from an old style of workflow called capture frame. So you're using an actual frame of your scene to determine the position of the bones for capturing. But this is pretty much a deprecated workflow. It has one or two uses, but the overwhelming majority of the time, you're never going to want to use capture frame. Instead, we're going to use capture pose, which uses the actual pose of your skeleton to determine what's captured. And in order to find that, we need to know where to start looking for our bones. So our capture SOP has in its extra region ... which means go up one level, and look for bone 1, and then look for the C region inside bone 1. But the deform SOP isn't necessarily going to have this information. It's just going to be using the point attribute, and the point attribute just has bone 1 / C region 0, and 0 means the first of the regions. It could have multiple regions. So it needs to know where to start looking, and that's what this PCAP scale root is. So the deform SOP will say, oh, okay, I start up one level, and then I find a bone 1, and then I go inside bone, and I find the C region. And that really is all that capturing in Houdini really is. We have some geometry. We use a capture method, either region or proximity or biharmonic, to establish our capture weights. And then it's these capture weight attributes that are used by the deform SOP to actually deform the geometry. So now if I rotate my bone, you can see that those points that have been captured are moving along with our bone, but those points that haven't been captured are staying where they are. So now that we've taken a quick look at what capturing is in Houdini, a question might arise, and that is, how does the deform SOP know how to move these points in space just with those attributes? Well, how it knows is this C region SOP inside the bone object. And you'll see that lots of this C region's parameters have been promoted up to the top level here at the bone. And that's on this third tab, the capture tab. So the deform object is looking at, again, this C region, and it's comparing two sets of parameters, a capture set of parameters and a deform set of parameters. So each of these capture region and deform region have shaping tools here. So if I have this capture region and I move this bottom height parameter, what I'm doing is I'm changing the shape of the capture region. So I can show that capture region here. And here I'm looking at the deform version of it. But if I go to Edit, Objects, Capture Pose, so this is an override. You can see that I'm kinematic override, bones are in capture pose. You can see that everything seems to be fine here. There's no weird distortion. But what's happening is that I have a capture bot height of 0.7, but a deform bottom height of 0.3. So there's a difference between these two sets of parameters. And this is what the deform SOP uses to determine how to move those points. So if I turn myself back to none, you can see that the deform SOP has seen the difference between these two sets of parameters and has moved the geometry accordingly. And another important area is this bone capture pose down here. And these parameters get set when we execute a capture command. And I can demonstrate that if I turn this off. If I draw another bone, just from here to here, where's that bone? If I go to its capture page, you can see that this bone that we've been working with was just a default bone. So all of its values were at default. But this one I've drawn in the viewport. And so it has a slightly different top and bottom cap. And it has a definite world space position here, which is slightly different than the default bone. So this is an initialization of this capture pose. But if I move this around, like I put some crazy numbers in here, you won't see anything happen, because right now this chain bone 1 is not a part of our capture, and so this capture pose isn't really being used by anything. But if I go back to capture geometry, and again I'm in regions, my method is append, and I'm using individual bones, and I select the geometry that we've previously captured, accept that selection, and then add this chain bone 1. If we look at the parameters here, let's just look at this bone rotate Y parameter. It's negative 1099. When I hit accept on this capture tool, you can see that it's changed now. It's just down to 20 degrees. And that's because the act of capturing the geometry with this bone, the first thing that the capture tool does is it says, okay, this bone is in this position. So in order to capture this bone in this position in a sensible way, I need to set this capture pose to the position of the bone. And that's what's represented by these numbers here. So now we can go into our grid geometry, and we can see here's our original capture of that default bone with its red color. And now we have an additional capture of this bone. We can turn that one on, and it's got like a purple color. You can see that those are overlapping. And then the deform is going to pay attention to both of these bones. And where they overlap, they're going to fight for supremacy. And you can see one of the differences here is this bone capture has destroy existing weights. So the first time you capture something, it'll be on by default. But because our method, if you remember, go back to capture geometry, our method here was append. Then the next capture that we did is going to turn that off. So this is saying there might be capture weights coming into this new capture, and I don't want to disturb them. I certainly don't want to destroy them, but so I'm going to turn that off. And then there's a blend factor here. So if I go to color by capture region, you can see that this second one is kind of just overriding the first one wherever they overlap. But I can blend that out a little bit. So now I'm getting more of a, I guess, a 51-49 blend between these two bones. I can see that if I rotate this new bone. So now those two bones are sharing this area of overlap. And that's something that the capture regions will do automatically. This central region, the weighting is going to be 1, but in these top and bottom cap areas, these will provide a nice blend. So that's how you get things like elbows that are blended nicely. So the important thing to understand here is that for each bone, there is a region associated with it. And that region has essentially two shapes, two sets of parameters that drive it. One is a capture state, and the other is a deform state. And that we compare those values to determine whether or not these points should be moved and deformed. To explore each of the different capture methods, I thought it'd be better to have a little bit more interesting example. And so in this scene, I have this tower geometry. So it's got basically a big giant cylinder with some of these spiky things pointing out of it. And then I've gone and drawn bones in a fairly simple network. And you'll notice that these bones don't follow up through each of these spikes. And I'm doing that just to illustrate how the different capture methods will deal with geometry like this. And then on these bones, I've just put a simple example of some animation. So we get some curling action, and we'll see how that the different methods will deal with that animation differently. So we've seen the region capture earlier, but we're going to go through each one individually and see how they differ. So to start with, we'll do capture geometry, and we're going to say regions, and we're going to choose our method, and in this case, append and replace. And we saw append earlier, that if there's an earlier capture, it will turn off destroy existing weights. But if it's set to replace, then it will have that destroy existing weights parameter turned on. So that's what's going on here. And then before we were using individual bones, but you could also use root of skeleton. So let's see what happens when we use root of skeleton. So again, we're prompted to select the geometry objects to capture, then press enter to continue. So again, I'm going to select my tower, accept selection. And now it's saying select the root object of the capturing hierarchy, then press enter to complete. So what it's asking for in this case is this tower root, or even this tower bone 1. And what the tool will do is it will look through this entire hierarchy, and any object that has inside of it a region or a C region, it will use that C region. So I'm going to select tower root, and I'm going to accept the selection. And again, in the viewport, we can see that some of our points have been colored because they've been captured. So I'll hit escape, and let's take a look at our network. I don't need this null. So this looks exactly like we saw in our earlier example. We have our deform SOP, and then we have our bone capture SOP. And it's filled in for us all of the bones that were found in this whole network. So just selecting that root, the tool has gone and found all of the objects that have a C region inside. So that's pretty handy. But of course, if some of these bones were over here, and that maybe they were attached to this hierarchy through a constraint or through a channel reference, then choosing root of the hierarchy wouldn't find those bones. So you would have to select those individually. But if you know your hierarchy is all connected like this, then you can just pick that root and it will find all the other bones. So back in our capture, if we display, we can see that our bones have these regions, but the regions don't really cover much of the geometry. And we can demonstrate that by putting the display flag on our deform SOP, going back up and looking at our animation. So the bones are moving and they're dragging along those points that have been captured. But clearly this is unacceptable. So what can we do to improve this? Well, the first thing that we can do here at the object level, even though this has still been captured, we can modify those capture regions. And we don't have to select each bone and come over here and try and, fiddle with these parameters. Houdini has some tools that will let us do that here in the viewport. So one of those tools is called Edit Capture Regions. So now we're prompted to select the bones to edit. And we're seeing this little preview of what our regions are selecting. So let's just grab this big green one here. And now we can see we have a transform handle, so we can move this around if we want. You can see that as I'm moving it, I'm capturing more points. But most of the time you wouldn't want to offset a region like this. Sometimes you would, but most of the time you want it aligned with your bone. But what we do want to do is expand these region, the top and bottom caps of the region. And we can do that in a bunch of different axes. So that one's better. It's capturing more of this area. We can also move the length of them a little more like that. So that's a little bit better. And if we hold Shift, you can see that if I move that one, it's moving that one alone. But if I hold down Shift and move it, it will move both the bottom and the top at the same time. So that makes it a little easier. So I can go through here, go through all of my bones, each one at a time. I don't think those are selectable. Yeah, the bone will need to be selectable in order for you to do this, or you could select it in the network. But I could go through, and then for all of these bones, make those edits. And now I can escape out of this tool. And because I didn't do this to all of them, it'll still be kind of crappy, but you'll see that some areas have improved quite a bit. Like those two bones that I did have improved quite a bit. But one area that we're not going to get at all, if I go back into the Edit Capture Regions tool, what are we going to do about this stuff up here? There's no way that we can, in any reasonable way, make a capture region that's going to encompass all of this without doing something really crazy. See, we can't even rotate it, so that's a problem too. So how do we do this? Like, this is nuts. You don't want to have to do this. So we'll get rid of all those edits. So capturing by region is very, very good. There's nothing wrong with it at all. But there are situations where it just falls down. It's just not going to give you the kind of end result and also ease of use and maintenance that you're going to be looking for. And we'll see capture region used to better effect later on. But for now, let's just move on and look at capture by proximity. So we don't have to get rid of anything here. In fact, we can just break that connection. So we could experiment with capture by region and see how it performs for us. And if it's not quite what we want, we don't have to lose that work. We can just set it aside and try something else. So let's try something else. Let's try proximity. So again, we'll go back to capture geometry. This time we'll use proximity, and we get the same method and selection method, and I'll leave those alone. So again, I'm going to select my geometry, accept that selection. I'm going to select the root of my hierarchy, and I'm going to accept that selection. And now you'll see quite a difference here. You can see that almost all of our geometry has a color which indicates that it's been captured. So let's escape out of that. We'll go into our geometry and look. So we have a new deform SOP because it's been provided by the tool. And now we have this bone capture proximity SOP. And it's very similar to the region capture. We have this hierarchy. We have our extra regions. We are using a capture pose. And then on our coloring tab, again, we have this point coloring as default source color. So we'll change that to color by capture region. That's the same as this down here on our bone capture SOP. And then we have this new one called weighting. And there's a few options here. So the weighting method, closest region object, or closest connecting region object. Closest region object is always going to be fine. And what that means, if I ghost other objects, is that every point is just going to look for the closest region. Right? So this point is going to find this guy, and this point is going to find this pink one. And then we have these sort of drop-off and max influences. So should this point be affected by 1 bone or 2 bones or 5 bones or 12 bones, we can drive that here. And then the drop-off, I think we can expand this guy a little bit if we increase our drop-off. Yeah. So you can see I can pull the effect back. So if I wanted to get more of these spiky things, the default is pretty good down here, but I might want to increase that. So now I'm getting more and more and more. But you can see after a while, I'm still not getting some of these guys. So I have to jack it way up. But by doing that, I'm also blending more of this. So you can see that this area is being affected pretty much half and half by these 2 bones, which may not be what I want. So while proximity is giving us a much better initial capture, and if I look at our animation, we can see that, yeah, everything is moving, but we're getting some pretty weird distortions all throughout here. So that's not awesome either. Now, again, we have tools to help improve all of these situations. But let's try Biharmonic and see what that gives us. So we can, again, just set this aside. We can reuse it later if we want, or we can compare these two pretty quickly. But let's try Biharmonic and see what happens. So again, capture geometry. Our method is going to be Biharmonic, or type is Biharmonic. Method, again, is append. Again, we can select the root of skeleton or the individual bones. And then we have these 2 new parameters in our tool, max iterations and high precision. These 2 really just affect the amount of work that the Biharmonic capture is going to do. And we've found in our testing that number of iterations at 1 is almost always just fine. In some certain situations, you might want to bump that up to 2 or 3. But for the most part, you'll never have to really touch this. But let's continue. So again, select the geometry objects to capture. So we'll select our geometry. And now select the root. We can select the root, or again, we can do individual bones if we want. Because all of these methods are all using that region to determine how to capture. So we've selected our root, accept that selection. And what you'll notice is it's doing a little bit of work here. It certainly took a little bit longer than either the regions or the proximity method. And we'll find out why that is in a second. So I'm going to escape out of that tool. And we can see, if we scrub our animation is way, way better. Like there's no weird distortion in any of these guys. And well, we have a little something here and here. But overall, this is exactly what we might want. The central tube thing is deforming nice and smoothly. each of these spiky things is deforming as if it were a rigid, spiky thing. So we just have a couple problems in there. So let's find out what we have going on here. Unlike, let me make some more room. Unlike the bone capture and capture proximity, which just rely on one SOP plus their deform to operate, the bone capture Biharmonic uses a few SOPs. So again, it made a bone deform for us. So we can move that down. Made a stash SOP. We'll talk about that in a second. But these are the meat of it. So again, we have our tower, and we have this bone capture lines SOP. So what is that? Well, the first thing that the Biharmonic system needs is to know about our extra regions, the region SOPs inside of our bones. So the tool fills this in for us. And if we display, turn off other objects, we can see that this bone capture lines SOP has made a bunch of lines for us. And those lines represent, if I just do this again, so I'm going to ghost other objects so I can see the bones. So those represent the bones themselves, and more accurately, the regions inside those bones. And so you can see that there's some parameters for how that's being built. Most of the time, you don't need to touch any of this stuff. But down here, Use Bone Link has been turned on. If I turn that off, you can see that these kind of shorten up a little bit. Let's see if we can see what's going on there. So you'll remember that if I can, I wonder if this is going to work. It might work. You can see this orangish region here around this bone. You can see where the central section begins and ends, just there. If I turn my display back to my bone capture lines, just remember this segment here. There's our bone. Hide other objects. Now you can see there is a line that corresponds pretty much exactly with that region, that central area of the region. So that's one of the options on the bone capture line, is to just take that central region of the capture region. But you may want the behavior of connected bones to be a little more accurate, so you'd use bone link. And what that's going to do is the length of this is going to be the entire length of the bone, not just that central area of the region. So use bone link. And now we use the entire length of the bone. So I have a bone here and then another full bone here. So what are these lines? We turn on the point mode, or rather point display. You can see that each of them is just a simple polygon line. Well, what's this used for? Why is this even useful? If we middle click on this bone capture line SOP, we'll see some things that we recognize. Specifically, we have a bone capture attribute, a PCAP frame attribute, and a PCAP scale root attribute. So these are the exact same attributes that our bone capture SOP created and that our bone capture proximity SOP created. So the first part of the Biharmonic workflow is to get the regions and to create some attributes, exactly the same attributes that our deform SOP needs. The second step is to use this thing called a solid embed. And what this thing does is it creates a tetrahedralization of our mesh. So it takes this mesh and it makes tetrahedrons to fill this volume. So we can see that just by turning this on. And this is what took a little time earlier. So now we can see that we have this kind of, well, a tetrahedralization of our mesh. And if I use a clip SOP, let's just configure this. Like that. So what this clip SOP is doing is it's cutting our geometry. And so we can see into the interior of this tet mesh. So this is what it looks like in the Biharmonic workflow. But if I turn, or if I remove this lines input and I let it cook again, watch, you see how not only do I have sort of fewer tets and they're all kind of scrambled around, but I've lost those lines in the interior. So I'll connect that again and just watch down the central axis here and then across at this point when I reconnect this. So it's cooking and now it's done. So I've gotten some pretty definite lines through here. And these lines are the points that were created by this bone capture line SOP. So to recap, we have lines. Turn that on again. And these points have our capture attributes that we talked about before. So for each point, it has the appropriate attribute of its capture region. And then these points plus this original geometry are combined, and a tetrahedralization is made of both of them together. And that takes a second. And we can clip, and we can see that here are those lines, those points that have been added. So now what we have is a piece of geometry, and each of these tetrahedrons have points, and these points have attributes. Some of these points have capture attributes, and some of them don't. And we can, again, confirm that over here in the spreadsheet. So some of these points have attributes, but if I scroll down a bit, I should be able to see, well, maybe they all do. Oh, I'm looking at the wrong one. If I look at the clip SOP in the geometry spreadsheet, here you can see all of these points have the attribute, but there's no values, except for just a few of them. So these points have the capture attributes. None of these points do. And that's what the Biharmonic capture is going to do for us. It's going to say, okay, these points have an attribute. These points don't. So these points need to be solved. I need to solve the spread of these attributes. So the attribute's going to spread using the tetrahedron as the method of finding out where more geometry is. You can think of this a little bit like an infection. So we have some infected cells here, and these infected cells are only going to infect their neighbor. So this one isn't going to affect that one up there, but this one is going to affect this one, and then this one is going to affect that one. And so we have this infection of our attributes, and that's how it can spread up into geometry that's very, very distant from our actual region, because it's using the tetrahedrons to crawl all the way up. It's going to get all the way up, all the way up, all the way up. And so that's why it takes a few seconds for this Biharmonic to work, because it has to do a few things. It has to go and get those regions and build lines with the attributes. It has to make a tet mesh, and that, depending on the complexity and scale of your object, can take quite a while. And then it uses the those tets to spread the attribute. And then the final step is for the bone capture biharmonic to transfer the attribute from that tet mesh to your actual mesh. And each of these have some parameters that you can adjust. The solid embed, you may need in some cases, like in this case, you might want to have a little bit more tets to catch all of those points. And the biharmonic again has default source color or color by capture region. It has some diagnostic information that it can output, but it's pretty robust. It works really, really well right out of the box almost all the time. And we could see that when we had our deform, that almost all of this is just perfect. Like all this stuff down here is great. We don't have to touch this at all. It's just a few points up here that have gotten slightly the wrong attribute. And I have an example. Where is it? There it is. This is one that I made earlier. If I go in here to the biharmonic, so again, I have our lines, and then on the solid embed, this one's taking just slightly longer. And then again, transfers the attribute. Whoops. So that one's perfect. All of these things have a nice smooth deformation and then a nice rigid deformation here. And the reason is that the attribute at this point associated with the bone that's right here is spreading up through this geometry. But the attributes in this area are not jumping over and infecting this area, because this infection, if we want to continue that analogy, the infection can only be spread by contact, not in the air. So those are our three capture methods. We had our region method, which, as I say, it seems like region in comparison to proximity or to biharmonic would be not as good, that you might want to avoid region just because it has some deficits and it takes a little bit more work. But region is very, very fast. And for situations that it works well on, it works really well. And so don't avoid it unnecessarily. Proximity is very good in certain situations. But again, sometimes in order to capture all of your geometry, you really have to crank some of these numbers, which can hurt you in other areas. And biharmonic, again, is it's excellent. It's the new default in Houdini now. We try to push people towards using it all the time. But it does have these little extra steps. And for some extremely complex geometry, building a tet mesh can be a little bit time-consuming. But we'll see when we capture our soldier that there are some very cool advantages to be able to build a tet mesh in a number of different ways in order to feed the biharmonic. One thing I will point out just at the end here on the biharmonic workflow, because these two steps can take a little bit more time, and I'm not talking about hours, but it might take 15 seconds or 45 seconds, something like that, to build the tet mesh and then to transfer the attributes. Because this can take a little time, we're adding by default this stash SOP. And all that the stash SOP does is it takes its input and it literally stashes it. So all of the information here, all the geometry and all the attributes that it has as its input are actually stashed inside of this node. And what that allows you to do is you can have your deform on. Oops. I don't know what's going on. Oh, I have the other one displayed. It allows you to have your deform running, but prevents anything up here that might change from affecting your deform. So it's like a brick wall. It just says, I'm not accepting any input until I restash the input. So that can be helpful if you're doing weight painting and stuff, and you don't want some slight little change to cause this to cook again, which, as I said, can take 45 seconds or whatever. So that's why the stash SOP is there. But one thing that I will mention about the stash SOP is that if you have one of these that is stashing all of this geometry and you save your HIP file will increase in size according to how much information is in this stash SOP. And additionally, if you have multiple stash SOPs, let's say you're stashing different versions of a biharmonic capture or different versions of whatever it is, then all of those stash SOPs are going to increase the HIP file size. So it's something just to be aware of. They're very useful, stash SOPs, but they do come with that caveat that they are like a brick wall. Nothing up here is going to pass through to your deform unless you update the stash. And additionally, they do hold lots of information that can bloat your HIP file just a bit. So if you notice either of those two things happening, look for your stash SOPs and see what they're doing and how many there are. There's a couple of things that I'd like to mention about Biharmonic and how it differs from other capturing methods and things you need to look out for. And so for these examples, I'm going to use a line and a ribbon and a few tubes. So we have this line, and we want to capture it with these two bones. So to start, we'll use region, and I just have this set up with a switch. So if we deform these two bones, we get pretty much what we expect. The points that have 100% weighting to this green bone are moving 100% with it, and then these 2 points are kind of sharing the weights between the green bone and the red bone, and so they're deforming in a little bit more of a smoother way. Put those back to 0. And if we look at capture proximity, we're going to get pretty much the same, but because in capture proximity, our weighting here is a drop off of 1, so we're getting more of a blend between the two. And as we saw before, we can tighten that up by reducing that drop off. So maybe go way down there and we can see that the sharing between these two bones is a little bit tighter. But again, if we switch over to the deforming the capture and we rotate these two bones, we get pretty much the exact same result. So what do we get when we use Biharmonic on a line like this? Well, again, we have to get our bone capture line geometry. So this is lines that represent the full bone, and these points have capture attributes. But when we come to our solid embed and we want to make a tet mesh of this line, we're going to encounter some interesting things. If we have enlarge input mesh set to on, then this is going to give us something usable. But by default, the capture Biharmonic tool is going to have that off. And you can see what we have here is we have some tets. There are 1 or 2 in there, believe it or not. But they're really not any good. we're not going to have much confidence in the capture of this. And so in this case, we would have to know that we have this ability to enlarge the input mesh, which again is just our line, but we can enlarge it using this parameter. And that will puff out the input mesh before a tet mesh is built from it. And then we have this offset parameter. So we can reduce that a little bit, and you can see that we can get a pretty good representation of our line. Again, it takes a few seconds. So that's pretty tight. But if this line were part of something very, very complex, let's say we had lots of little lines that were all either intersecting maybe or close together, that making a tet mesh of it might be a bit of a challenge. And so in that case, using region or proximity might be a better bet. But you can see that once we've, in this case, if we make a nice fat tube to represent the tet mesh for our line, then we can capture it. And it will deform just like the other methods. But you can see that there is a definite difference in the way in which we had to capture it. We had to take into account this incoming geometry. So especially for open curves, or in the case of a ribbon, we're going to have to keep that in mind. And we can look at our ribbon. Again, I've set these two up, capture region and capture proximity. And you can see that they're the same as they were with the line, and those will deform fine. But again, when we come over to our capture Biharmonic workflow, the line that we've made from our bones is good, but then this is the tet mesh that we get. And you can see that it's perfectly flat. It's not extending out very far, certainly not enough to reach the extents of this ribbon. So again, we would have to enlarge that mesh, and we get something like this. So maybe bring that down to 1. That's still not great. So again, we'd have to play with this a little bit. And so while Biharmonic seems, for a lot of things, particularly characters, things like that, it's the absolute best option. In some situations, you don't want to just assume that it's going to be the best, at least not without a little bit of manipulation. And we can see that in another example on this tube that has open ends. The Biharmonic tools will try their best. So here's our line, and here's our solid embed without enlarged mesh on. And you can see that it did a pretty good job. So those tets are filling the interior. And they're probably pretty reasonable for this tube. But if our tube were a little larger, so if I made its radius, let's say 0.4, and put that through the solid embed again, well, that still works. But at a certain point, it's going to fail. Right? It's just not going to be able to complete that as a tet mesh. We could enlarge, but again, that may not be suitable. So the solid embed, it is a digital asset. You can go inside and see what it's doing. So it tries its best to accommodate all kinds of geometry. And in the case of a tube that's, as we saw, a little bit smaller, 0.4, it'll try and cap that tube. So it'll try and put a cap on the end there and then fill that with tets. But it won't work all the time. So again, pay attention to what it's doing before you just sort of assume that it's going to work just fine. So another example here Get rid of that. In this case, we have an open tube. So it's a tube that has a little section cut out. So again, we bring in our lines from our bones. And here is the Biharmonic, the solid embed tet mesh that it's created, which is really not great at all. So this tube was quite small, radius of 0.1. So in our other example, it worked out just fine. But because it has this cut in it, the solid embed just didn't know how to deal with that. It did its best, but its best just isn't good enough. So in this case, again, we would have to enlarge that mesh, which we may not be able to do in a regular workflow. So another situation is that if you have a tube with a bunch of stuff around it, not really sure what kind of situation you'd have with this, but let's just pretend that this was the situation you had. You had an open tube and you had these little squares, little boxes around it. And maybe this was a creature or some sort of mechanical thing that needed to deform. If you do a Biharmonic on it, this will take a few more seconds than usual because it has to make a tet mesh out of all these little guys here. So we'll just give it a second, 98%, and done. So you can see that it managed to make a tet mesh out of all this stuff, and it seemed like it made a nice solid tet mesh of our tube. But if we use a clip sop again, we can see that it didn't make an interior at all. So all of this has failed. But it did make a bit of a tet mesh on the ends, and it made tet mesh for all those little cubes. So if we were to put this through the Biharmonic, we'll stash that and then go to our deform. We take our two bones. You can see that we're getting something of a reasonable deformation. But what you may not realize is that the only points in this geometry that are being properly deformed by the Biharmonic are these guys on the ends, here and here. All of this stuff in the center is actually getting its weights through a proximity method. And the reason for that, if we go back inside, look at our clip again, is that the way in which Biharmonic operates, as we saw before, here are some points from our lines, from our bones. So these points have a capture attribute. And when we go through the Biharmonic, the capture attributes on these points is being spread out to here. And so the ends of these tubes are getting the proper capture attribute. But this geometry out here, these tets are not connected. So how is the attribute going to spread out to here? Or indeed, out to the geometry out here? It's going to spread from the ends into the center. So the geometry here in the center is not getting the proper weighting from here. It's getting it from way over here at the ends. And this geometry out here, it's getting an attribute transfer from here out to here. It's not getting that spread through the tetrahedrons. That spread ends right there. And then there's more geometry out here. So we can see there's these guys, but they're just getting transferred. So the actual deformation that we're seeing isn't really what we want, right? This is effectively the same as proximity capture because it's based on the distance to the mesh. So over here, I've done something a little different. I've captured just the tube on its own. And we look at that clip-sop, we can see that we get all the tets in the center with that attribute. And then I know that these little boxes aren't going to get the spreading attribute anyway, so I just leave these alone. And now when I combine them in a biharmonic, we're getting a much more solid deform through the center. You can see the angle there is much more definite. It's not as soft as that proximity method was. So those are just some things to look out for when you're using biharmonic. It is a vastly superior method of capturing and deforming than region and proximity in a lot of situations, particularly organic characters. But if you're dealing with sci-fi characters and fantasy characters, they often have weird stuff all over the place, or have 9 weird arms. And so in those kind of situations, you really do need to pay attention to your geometry and pay attention to how these tet meshes are being built. And use a clip-sop. It's a really handy way of just cutting your tet mesh in half and seeing whether or not you get these proper points from our bone regions all the way through. You don't want to see that, right? Because this is all just wasted. So, some little tips about biharmonic that I hope are useful. Next up, we're talking about how to improve these captures after our capture, how to fix little things like this with some of the tools that Houdini provides. Another way of capturing geometry is called wire capture. And for that, just to demonstrate, I have a grid. I'm going to go inside, and in the viewport, I'm going to start making a curve. And before I end this, I'm going to change it to a NURBS curve. So I have a curve, and I have my grid. And I'm going to put down a wire capture. A wire capture has 2 inputs, the geometry to capture and the wire to capture with. And when I first display it, you'll notice that we have these little guide radii along our curve. And the first thing I'm going to do is turn on visualize weighting. So now we get a little bit better indication of what's being captured. And then on the capture tab, I have 2 options, initialize from primitives or initialize from groups. And I like to use just initialize from primitives. What that's going to do is it's going to take the primitives of the wire input and create a parameter here for each one. So if I have 10 curves, I'll get 10 primitives, each with its own set of parameters. So these parameters are effectively the min and max weighting that this curve is going to apply to the points that are captured, fall off, and then this U radius and lookup is sort of the important one. And you can see that right now it's going from 0.3 to 1. If I increase this U radius, you can see that it overall increases the radius of the curve. But it's kind of global. Like I don't really have any control over tapering. I can't have a large radius here and then a small radius here. So one of the ways that you can change that is to put a key here. So we're going to drive this with a channel. So I can Alt and left click on here and create a key. Then I can go into Scope Parameters to bring up the animation editor. And I have a key here at frame 1, value 1. If I come over here and Alt click here, I'm going to put a key at 100 with a value of 0. So now I have this little curve. And if we have a look at what that's done in our viewport, you can see that I'm getting this tapering off to nothing. So let's raise this up a bit. So that's at 1. Let's go up to something much higher. So now that's 6.3 down to 0.4. So you can see that I'm able to shape this capture region. I think maybe that will be a little bit better. Actually, let's increase the resolution in our grid. 30 by 30. So now we've taken this curve and we've captured this geometry using the wire capture. And you can play around with these as much as you want, but having this a little channel in the lookup is really quite handy for shaping. But how do we deform this? We don't use a bone deform because we're not using bones, but we do use a wire deform. And a wire deform has 3 parameters. It has the geometry to deform, so that's our original geometry. Then it has the rest wire, so that would be this guy. And oops, forgot. The geometry to deform should be the geometry that has the capture attributes. If we middle click, we can see we have a wire capture attribute. So this is the geometry that we're deforming. This is our rest curve. And then we want a deforming wire. So what do we do with that? Well, what we want to do is we want to have just our default curve, and then we want to have any modification to that curve that we've made. So a simple way of demonstrating that is to just throw an edit onto that curve. And I can grab one of these points, and I can just edit it. So now we have that curve, and we have this edited curve. So we can put that into our deforming wires input on our deform SOP. And before we make it visible, before we display it, I'm going to turn on Visualize Weighting again. And on the Deform tab, I'm just going to say Initialize from Rest Primitives again. And that'll pop up this value here. So I'll get primitive 0, I have a scale, and I have a U deform. So now I can display this, and we can see that we've deformed our grid using the difference between our original curve and our edited curve. And this doesn't have to be an edit. This could be, you could send this curve off to a DOP simulation, or it could be an animated curve, anything you want. But what you want to make sure is that the number of points in this curve are continuous, are the same. So the rest curve and the deformed curve are essentially identical, except the deformed curve is moving around, doing stuff. So both into our wire deform, and that will deform our geometry. And I can go back to my edit and make changes to deform the mesh. So this is a little outside of the scope of this particular tutorial series, but I thought it would be handy to show you because it's useful and pretty cool. No matter what method you might use to capture your geometry, there are some tools that we use to improve those captures. So I'm going to capture this arm, which has some simple animation on it, using regions. And then I'm going to use each of the tools to help improve the capture that I get from regions. So the first thing that I did was I used the Edit Capture Regions tool to make sure that my regions were the proper size. So to use that tool, you just select the bone and you'll get the region associated with that bone. And you can see that I've shaped this one to better fit the geometry. So it's a little fatter up at the top near the shoulder, a little thinner down by the elbow. And I showed you a little bit of this in an earlier example. You can grab these little triangle things to shape this region. So I can shorten that up. And if I hold down Shift, I'll do two at once. And then I can lengthen it or shorten it, depending on my needs. So in preparation for capturing with regions, I just went through and checked all of these to be sure that they were the size that I wanted. So this might be a bit big. So just go through and do the best you can. And it can take a little time to do things like fingers, but it's fine. So having done that, now I'll use the Capture Geometry tool. I'm going to use regions, and then I'm going to use individual bones. So select my geometry, accept, select each of the bones that I want to use. Whoops. And accept. And I can see my default capture. So I escape out of that. And because I've gotten the capture SOP and a deform, right away I can scrub through my animation and I can see just how good or bad it is. So I can see that obviously my regions in my hand, particularly in the fingers, aren't quite right. I've missed some points. Now I can go back and adjust these regions just again by invoking the Edit Capture Regions tool. And it will show me the color. Now that these bones have been used to capture, it'll show me the color associated with each bone. So here I can see that I need to expand those out a little bit. Expand that out a little bit. So I need to go through and fix all of that. But sometimes just adjusting a region isn't going to be good enough. Sometimes the geometry is kind of weird, or, well, a whole host of reasons. So I'm going to do my best just to reduce the amount of work that I have to do with other tools. And this isn't great here. So you can see there's some areas that are easier to get than others. But I'm going to go through, do my best, and then I can scrub again. You can see that it's better, but not quite perfect. So what are some of the other tools that I can use? Well, we could use Edit Capture Weights. This is a handy one. I can use this in two modes. I can use it in a viewport tool mode, or I can use it via a spreadsheet. And both of those work based on selections. So I know that the tip of this finger isn't being captured properly to this bone. So what I'm going to do is I'm going to select the points whoops, make sure your geometry is selectable. I'm going to select the points that I want to capture to a particular bone. And you can see as soon as I selected these points, all of these bones got this little diamond-shaped thingy. And you can see that these are at the root of the bones, and you can see that they're hollow. You can see that they're not filled in. Whereas this one is yellow, and it's solid, and it's more toward the tip of the bone. So that's indicating a few things. One, that these bones have zero weight on these points because they're empty diamonds, whereas this one has a solid diamond. That means that these points are associated with this bone in some way. And if I select this diamond, I can move it along the bone. And you can see it says negative 0.641. So I'm reducing the weight, or I can increase the weight. And you can see that as soon as I let go, this will update a little bit. And this works pretty well. You can get some fairly fine adjustments of your weighting. But sometimes, like in this case, I don't want to just add a little bit here or take away a little bit there. I know that I want all of these points to be 100% to this bone. And this method is just going to be adding a little bit here and a little bit there. But what I can do is I can right-click on this diamond thing, and I can go into what's called absolute mode. So if I select that, now I get a square, or a kind of a rectangle-y thing. And that, I can go right to 1. And you can see the difference in the visualization there. I have a bracketed 1.0. So I know that that's 100%. Or I could use it to go, exactly to 0.5% or 0. You can see that the geometry's turned white. So I'm going to go 100%. And I could go through that for all of these and just be sure that they were all nicely clamped down at a full 1.0. And then I might want to grab these points and just increase them a little bit. I could just grab 1 point. Where do I want that one? It's not captured at all. Let's put it on that guy there. I can grab this guy, give him a little bit. So I can go through and use this tool interactively to weight these points. But I could also select some points and come up here and bring up the spreadsheet. So if I do that for these points, I can see that I spread this out a little bit. Here's my object, arm, and then the point number. And then here, it might be a little hard to see in the video capture because of this green color, but this is indicating the bone and the C region that these points currently have values for. And then it lists the values. So you can see all of these points are 100% to this bone. But let's say if I select these points, now you can see that there are 2 bones involved with these points. Some of them have a 0 weight to one of the bones and a 1 weight to another bone. But some of them have a mix. You can see this one, 0.1434, has a 0.21 to this bone and a 0.78 to that bone. And if I wanted to edit these, it's as simple as selecting the cell that I wanted to edit. So I could grab, say, these ones, and now I can edit. I could just put 1.0 in there, or whatever I wanted, and hit enter. You can see that these are now edited, but you can see that I have a 1.0 and a 0.16. So this is above 1. because all of the points will only have a 1.0, a normalized value. But right now this isn't normalized. So I can come up here after I've done the edits that I feel that I need to do, and I can say normalize. And that will normalize all the values. So this edit capture weights tool is pretty good if you need to grab some specific points and do a definite, I know the values that I want, or I know that I want this point to be like 0.2 or something. It's really handy for that. So that's a second way of altering our capture. And the third way, the way that you're probably already somewhat familiar with, is to paint. So let's do that. We can tab in the viewport and start typing paint, and we get this tool called Paint Capture Layer. We're not going to talk really much about the layers of the Paint Capture Layer tool. It's not a workflow that's really used much anymore. It's useful in some cases, but they're pretty rare, at least in my experience. So we've invoked this tool, and the prompt is telling us to select the geometry to paint. So select it, accept selected. And now the viewport has changed, and so has our network. This tool relies on a sort of configuration of our Houdini environment. So what we're looking at down here is the SOP geometry. And select that and hit enter again in the viewport. So now I'm in the Paint Capture Layer Paint tool. I have my deform displayed, but I have my Capture Layer Paint SOP selected. And that's enabling us to see our deform, but also manipulating our paint at the same time. So I can see that, gotta get some points here. So the way that this tool works is you have this kind of paintbrushy thing in the viewport, and then we have some options here. One thing that I would really recommend is, see how the paintbrush is kind of jumping around? Well, it's trying to align itself to the normal of the surface that we're currently over. And while that's useful, personally I find it very distracting. So what I'd recommend is to right-click and turn off Orient Brush to Surface. And that will give you just this stable radius. And then that radius can be adjusted up here, or I can hold down Shift and middle mouse, and I can increase or decrease that radius. And then we have a depth option here, which it's a little difficult to show, but if you can imagine, if I'm painting on the front of this thumb, I don't want to accidentally paint beyond and hit this finger. So that's what this depth parameter is helping with. And then the opacity is just when I stroke over something, how much of the attribute do I want to paint? And the default is at 0.2. But the most important thing is here at the top, this capture region. Right now it's empty, but if I use the drop down, I can see all of the bones that are currently associated with this piece of geometry, all of the bone influence that I can paint. So you can use that to select a bone, and then over here in the capture paint parameters, what I like to do is, again, visualize normalized weights and then visualize selected capture region. So that will show me just this bone that I've selected. Let's select a finger, it might be more relevant. So finger 3, bone 1, I'm just going to see the weights of that one bone. So there we are. And then additionally, you can ghost other objects. Now you can see the bones. And what you can do is use Control and middle click to select the bone that you're going to put up here in the capture region. So currently I'm painting with the hand bone, or I'm painting with the first bone of this finger. And then it's just like any other painting tool. So for this weird geometry that's getting stretched, I'm going to paint that to this bone. So I'm going to go down and see where those points are and see if I can. These guys are somewhat tricky. There we go. So I just clicked once and it got enough attribute to zap back up here. So now I can add a little bit more. Go get this one, which should be from here. And if you find that you've lost, my mouse is over here and I've lost my paintbrush, the paintbrush will only be visible when you're over some geometry. So if you need to adjust the radius, just put it over some geometry and then shift middle. So I'm going to make it somewhat big and come down here and just sometimes, there we go. Sometimes those are hard to grab. So we can paint, and our brush has a couple of options. Well, more than a couple. We have lots of these options, like radius is already up here in the viewport, but we can do things like soft edge is right now is at 1. But if maybe I'll show you how that works. So right now a soft edge of 1, if I just left click on this point right here, you can see that it gets a little bit of color. It doesn't get the full red of this color, but I have to keep painting. But if I took soft edge and I put it down to 0, that'll mean that there is no fall off on this brush. And it should get, well, my opacity. There we go. So it'll get the full color. So there won't be an opacity difference between the center of the brush and the edge of the brush. And all of these other brush parameters are fairly self-explanatory. They're a lot like painting programs that you've used before. You can also invoke symmetry, either reflective or rotational. And then the other things to look out for are, if I right-click, you can see again there's that orient brush to surface. But now I have my 2 operations available here. And by default, the left mouse is to paint, and the middle mouse will reduce. So I can paint, 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 reduce, reduce, reduce. Whoops, reduce too much. One thing that I like to do personally is have left mouse on paint and middle mouse on smooth. I tend to do paint and smooth more than I do anything else. So I'll put that on smooth final. And again, this layering workflow is a fairly in-depth thing that we can talk about another time. So I'm just going to use smooth final for my middle mouse operation. I'll bring my opacity back down to 0.2. So now as I go along, I can paint and then smooth, paint a little bit, smooth. And that's pretty much it. If you're painting and smoothing, you just need to put in a little bit of time, and you can get really nice results. So even in this case with the region capture, which initially, if you'll remember, was kind of bad, with just a few minutes, it's improved quite a bit. And I've only spent, maybe 15 minutes, and very little of that was doing work. Most of it was talking to you. But you can see that our fingers are pretty good. We might want to go in and adjust just where these upper knuckles are. We'll always want to work on our elbow and our forearm a bit. But not too bad. But it does illustrate the three methods of adjusting our capture weights. And you can see that these just will stack up. So that first method of adjusting the capture regions, that's not represented by a SOP, because that operation is adjusting the parameters on the bone capture region itself. But the second one, the Edit Capture Weights tool, uses a capture override SOP. And this doesn't really have any sort of history. So you'll see just the last operation that we performed here. But you can see that it's using a region. In this case, we actually selected a point, a single point, and we set its weight to 0.2. So that shows exactly the last thing that we did. We can also update point colors so that any edits that we make will immediately update what these points look like. So this one's pretty straightforward. And then capture layer paint, we went through that. So that will be represented by an actual SOP as well. And what I find in my workflow most often is that I'll do a capture and then I'll do some bulk overall fixes, either with a capture override through the Edit Weights tool or capture layer paint. I'll just go through really quickly and fix up the obvious mistakes and deficiencies in the capture that I've gotten. And then after that, I'll put a null down just in between the deform and the previous uses of these tools. And what this does is it will prevent a reuse of these tools. And what I mean by that is if I had this network, so I have a capture override and a deform, and I'm up here at the object level and I use Edit Capture Weights again, I select some points and I mess around, and I go into my geometry, that last thing that I did is going to use the first one that the deform encounters going up its chain. So it's going to reuse that capture override. But I might have done some work in here that I want to preserve, especially in paint SOPs. I might have done a lot of work in this paint SOP just on the hand, and I may not want to reuse that. I may want to make sure that that stays paint hand. So I'll put a null there, and now if I want to paint the shoulder, use Paint Capture Layer, select the geometry, right-click to accept, and now I can paint the shoulder, but you can see that I'm not reusing paint hand. Because this null is here, I'm making a new capture layer paint. So now I can say paint shoulder, and now I can mess around with these things. I can see what the shoulder looks like with the paint hand, or I could bypass that, or I could put it aside completely. So maybe I have two paint hands. Maybe I've painted one and had a look at how it deforms, but then I like, maybe it's not as good as I want it to be. So I can paint a hand in a separate capture layer paint SOP and have a look at what that one looks like. And I can compare them really easily without destroying the work that I've already done. So pretty versatile tools. I think you'll find you're going to use capture layer paint more than you will capture override. Some people quite like the spreadsheet workflow. I personally think it's crazy, but that's me. Although for certain things like getting very precise weights in weird little areas, the spreadsheet is extremely effective. But I find that I get most of my work done with capture layer paint. So those are some tools that are super handy for adjusting capture weights. I hope that was useful. So now it's time to rig our soldier. To start with, I've made sure that I've installed my soldier and instantiated him here in the network. You can see that he's a HDA and he's locked. So the first thing I'll need to do is right-click and allow editing of contents on this HDA. And then I'm going to turn off all of my controls, and I'm going to turn on display of all the bones. Right now we're viewing the proxy, but I'm going to turn that to deform. You'll see nothing really changes, and that's because if I go inside the soldier and then inside his body, I have his actual geometry, and then I have a null, which is just empty, and a switch, which is being driven by a display. So if the display is set to proxy, then this geometry object will display this null, and if it's set to deform, it will display this null, which currently just has his full geometry. But we're not really going to be using this much after this point. So I'm going to put a null right off of this file node, and I'm just going to call it capture, just so that we have a place to start from. So we can set that aside. So the method that we're going to use is Biharmonic, and there's a couple of things that we need to sort of get organized about right off the bat. One is that the geometry for our capture is selectable, so that it has this flag. And the second is to know what bones we actually want to use in our capture. And I know that all of our hand bones and our foot bones, our spine, and our head and neck, we're going to use all of those bones. But if you'll remember from our first series, we have these two upper bone and lower bone for our arm, but we also have, so we have this upper bone and lower bone, but we also have these twist bones. I'll just turn these on. So for each of the upper and lower arm bone, we have 4 twist bones. And the same is true for the legs, upper and lower. So in this case, I don't want to use this large upper bone. Instead, I want to use these 4 twist bones for my deformation. So what I've done, I can turn these off again, is if you'll remember in our first series, we used node groups to organize some of our bones and controls. So to retrieve that window in the network, I'm going to use Shift-Z. That brings back this little area here. You can see I've got all of these node groups. Just see a little more of this. So you can see here I've got spine bones, spine controls, and spine proxy. And this yellow area here will allow me to select just those nodes. So here you can see that I've selected just the spine nodes or just the spine proxies. You can see here in the network. So using Shift and Control, I can select just the bones that I want to use for my capture. And so I have, let's say, left leg bones. If we look at those, in this group, I've only included the left twist and the foot bones. I haven't included the 2 large bones. So keep that in mind. It's a very, very handy way of having lots of bones that are all in different areas, but you can group them very specifically. Like I have left arm bones, but then I also have left arm capture bones. So that's one way to differentiate these bones. So let's start with our capture. Tab in the viewport, capture geometry. I'm going to select this mesh. I'm going to accept that selection. And then for the bones, I'm going to come here into the node group view. I'm going to select head neck bones. You can see that they're selected. And then I'm going to control select left arm capture bones, which will give all of those. And then I'm going to hold control and click left hand bones. So head neck control bones. Oh, and I think shift maybe to add. That's correct. Head neck bones, shift left arm capture bones, shift left hand bones, shift left leg bones, shift right arm capture bones, Shift right hand bones, right leg bones, and Shift spine bones. So now in the viewport, we're not seeing that these two arm and leg bones are selected, but in the network, we can see that we have all the arm twist bones, that's the hand bones, and the leg twist bones. These are the ones we want to use for our capture. So I've selected those. I'm going to right-click, Accept Selection, and now Houdini is going to create that tet mesh that we talked about and give us an initial weighting. So we can deselect, we can escape out of the Capture Geometry tool, and if we bring back some of our controls, we can see right away that we have a capture, and it's a pretty good one. So let's go in and take a look at what we've got in the SOP view. So Shift Z to remove the node group view. And here we go. So if you'll remember from the last video, here's our Biharmonic setup. We have our initial geometry. We have our bone capture line SOP, which has gone out and retrieved all of those bones that we've specified and is looking for the C regions inside. So if we display that, you can see there are all the lines from our bones, show with points. And again, we're using the bone link to determine the length of that line. So if I turn that off, you can see that our upper arm has 1, 2, 3, 4 C regions, and the lower has 4 as well. And the same with our legs. But we want to use bone link. So we'll turn that back on. And then we have the tet mesh. Turn points off. And these default settings are pretty good. This character is just under 2 meters tall and has some pretty fine detail. The fingers are always tricky, but just as on default with enlarge input mesh turned off, it's done a really pretty good job. We can template our original mesh, and you can see that it's created some pretty good detail here. This might seem like it's failed, but these points on our mesh, they're not going to get weights from any other tet mesh except these ones. So having this little distance here is just fine. What you want to look out for are areas of high curvature like this. You want to make sure that this is well defined. And you can see that if I turn on enlarge input mesh and we let that cook again, you can see what it does. So it's basically enlarging all the surfaces, and by doing so, it's merged those fingers together. So we're not going to get a very good capture out of this. This will all be just mushy. And even if I lower this enlarge offset parameter, it's still going to be pretty mushy. So by default, we turn this off, and it gives us a much tighter tet mesh. And then from there, it passes it in to the Biharmonic capture, which calculates the weights throughout the tet mesh. And we can turn this capture by color or color by capture region on, and we can see our weighting. Then it goes into a stash SOP, you'll remember. So because we've turned on color by capture region here, if we display our stash SOP, you can see that our colors disappear because this stash SOP is storing data from before we turned this on. So in order to see that, and in order for any changes we make upstream to pass down to our deform SOP, we have to restash that input. And now our deform do its job. So one thing that I noticed earlier in testing this is that while overall our capture is really, really good, I mean, there's not a lot of work that we'll need to do to improve this. But I did notice that the hands, if I do a hand curl, and I'm just using a torn off parameter pane, which is off screen, to use those parameters. If I do a curl, I look at the fingers, they're all right. They're not great. They're a little soft in here. So one thing I can do is I can use the Edit Capture Weights tool or the Paint Capture Layer tool and just improve this a little bit, tighten this up a bit. But there's also something I can do before that, and it's up here in this Bone Capture Lines. Right now, if we display that, you can see that we're using the bone link. But I think for the fingers, we might not want to use that. We might want to use this, just the region length, by turning Use Bone Length off. But the problem is that I do want to use the bone link for the rest of the bones. So how do I exclude the hands? Well, the easiest way to do that, and you can see I've done a little test over here. I'll bring this over. I can get rid of this. I have another bone capture lines, and this time I've specified all of the bones of the skeleton, but I haven't included the hands. And you can see that just in this extra regions parameter. If you open up the node chooser, you can see that, and if I can find the hands here, you can see that I haven't included any of the hand bones. And then I have another one where I've just included the fingers. And this is perfectly valid. Here I'm just merging them together. So as far as the solid embed and the Biharmonic are concerned, these two nodes that are merged together and this single node are identical. It doesn't really know that there's any difference between them. So there's nothing stopping you from making very specific kinds of lines that go into your solid embed. Additionally, we can cut our geometry up if we want and make different tetrahedralizations of them. And we can merge those and then put them into the Biharmonic capture. So there's a great deal of flexibility afforded here because you have two areas where you're preparing your geometry and your capture regions to be exactly what you want, and then you're going to put it into the bone capture Biharmonic. So let's see what the difference between that should be. So this one with Use Bone Link, it's not updating for some reason. So here we have the body with Use Bone Link on, and the hands, oh, that's why, with Bone Link off. And we merge those together, and then we use that for the tetrahedralization. Give it a second to cook. So it's done. And the tet mesh looks identical. There's really no difference. But now when I put it into the Biharmonic capture, and again, I have to stash the input, go into my deform. Now when I use the hand curl, I still get a deform, but it's a little tighter. I'm getting a little better behavior out of this geometry. So that's something to really keep in mind, particularly with the Biharmonic workflow, is that you have been afforded this flexibility, both in the way in which you construct these lines and the way in which you ultimately construct your tet mesh. So play around with that. If you have Let's see if I can quickly show you an example. If I have an area of really high detail, lots of weird curvature, and then I have areas of really no detail. There's nothing special going on. These are just, tubes basically. Whereas the fingers are really special areas. I could do something where I could use a delete. I could take this hand so here I have body, and here I have just the hand. And I could use these separately. So if I have, I'll take this solid embed, make a copy of that, just let it cook. So now I'm going to make a tet mesh. Just using the body, like this. So I have this one. I can put a null down, just lock that temporarily. Now I can take another of these solid embeds, and this time just use just the fingers. So I'll make this tet mesh. And again, I'll lock that. So now I have two entirely different tet meshes. But with this body, I might use, I'll just let that cook again. I might use very different settings. I might use these parameters to get exactly the kind of density that I'm looking for in a tet mesh for the body. But then for the hand, I might need completely different settings in order to get the very fine detail. In the case of this soldier, I certainly don't need to do this, as you just saw. But it's perfectly valid to do so. And then I could take both of these, merge them together, and feed them into the Biharmonic capture. And there we go. Stash that input back into the deform. Oh, and it works fine. So it might seem a little bit convoluted having this two-step process where we make these lines and then we make that tet mesh. But that flexibility really comes in handy. And again, in this particular case with this soldier, I'm able to get good density here without having to make any kind of changes. I don't have to do these two separately. But sometimes you might have to. And having that ability to mix and match and really customize the kinds of geometry you're capturing is very, very handy. So I'm going to go back and clean this up, get rid of all this extra stuff we did. And then in the next part, we'll continue with the workflow. I've cleaned up our little experimenting in the SOP network. So now it's time to move on to the next stage that I usually do, and that is to test out the rig. I'll usually just grab like a leg control and move it around. Grab the arm controls, move them around. Just select various controls in your rig and see how they behave. And what you'll notice, at least in my case, most of these controls are working just fine. There's nothing, certainly nothing broken. Certainly room for improvement, of course, but there's nothing that is really sticking out as being a failure in any real way. A couple of things that I've noticed, though, right off the bat, is that because I only have 2 bones for almost my entire head, that when I rotate my jaw forward, it's dragging all of this face with it. So even though this is just a simple head and jaw rig for the head, I really need to fix this. So I'll be doing that for sure. And then the other thing that I've noticed is that I've accidentally, on purpose, put this elbow rotation way too far back. And so when I rotate the arm, it's really bending too far backward here. So I want to place this rotation point at the elbow a little bit more toward the center of the arm. Not right in the center, but just slightly back of center. Right now it's a little too far back here. So what that's going to cause is not only do I have IK and constraints on this arm, but I also have all those twist joints, the twisting bones. So if I modify the angle of these 2 bones, it's going to change the length of those bones. And so all of this stuff is going to be needing to be updated to accommodate that change. Additionally, we'll be moving our bone, which is going to change the relationship between our deform region and our original capture region. So I'm going to do those 2 things. But otherwise, I'm not going to actually force you to sit here and watch me painting any of these areas. You saw the earlier examples, and I wouldn't be doing anything different than I did in those examples, either with the Edit Capture Weights tool or with the Paint Layer tool. But I'll show you what my workflow would be to fix this head and then to fix this arm. I think those will be valuable things to see step by step. So we'll do that now. To address the jaw and head, if you'll remember, this jaw is dragging all the face with it. I'm going to make use of a couple of point groups. One of them is a head point group, and I've selected all the face and the jaw and the ears right to the back of the skull. And a jaw point group, which is just roughly the jaw, just straight across like that. And then I'm going to use 2 capture overrides, and these can be placed just in the network like this, or you can create one using the Edit Capture Weights tool and just grab some points, and then you can just hit Escape. And that will create one here in the network. So I just did that, and then manually I named them to be what they're overriding. And so in this case, Capture Override Head. So I know exactly what this node is doing. And then for its parameters, I just specified that head group in this override, and then specified the capture region that I wanted to associate these points with. And there's I can't quite see it, so I'll reverse this. There's a drop down here that'll list all of the regions that you have available. So I just found the head bone. And then the operation I want to perform is to replace the existing override. So I just chose that from this drop down. And now I can give this a weight. You can see that this is without the override. And now I can dial in exactly as much as I want. And in this case, I went right to 100% right to the head. And then I just did the same for the jaw. Put in the jaw point group, specified the jaw capture region, replace, a weight of 1. So now, if I connect that to my deform SOP, and I rotate the jaw, so the jaw is just moving the jaw. And this area here, because these points were not part of the jaw group, they're not moving at all, or only slightly. So I'll have to go in and paint that, but that's fine. And then for the head, if I rotate the head, you can see that it rotates just that head area. And because the jawbone is a child of the head, it takes the jaw with it. So having done that, you can go back up to the object level, and now we can use the paint capture layer. I can select my geometry, accept that. It pops me back down into the SOP level, and I have a capture paint tool. Now I can rotate the head a little. Just re-enter that. Turn off orient brush to surface. Reduce that. So the back of the neck is pretty good, but I can smooth that out a little bit. I can pick the jawbone. And if you find that these bones are a little distracting, you can always just hide the other objects. So just smooth that out. And at this point, it's just a case of painting and smoothing. And rotating your head and jaw up and down, left and right, until you get the kind of deformation that you're looking for your character. So you just want to continue to move all around. Just move the jaw. So now we can smooth this in. And this is just rough. This isn't going to be perfect for production weighting, but certainly plenty good for roughing in the animation. And obviously, this character might have a full face rig. So what we're doing now is really just maybe for blocking or, roughing in whatever performance this character might be doing. So you just continue on like that until you get the result that you want. So next we'll fix up this arm. Before we fix our arm bone positions, it'll be a good idea to review the kind of things that we need to look out for when doing this kind of operation, because we have a lot of things that are dependent upon the positions and orientations of our arm bones. So first up is this clavicle, which has a constraint to this first arm bone. So we want to be aware of that. Secondly, we have constraints that are driving our hand bones and hand controls. So we want to be aware of that. And then third, we have these twist bones that right now are parented to both the upper and the lower bone. So when we move the positions of these bones, All of these things are going to be affected. And it's important not only to be aware that they are going to be affected, but also how to mitigate any changes that will occur. So the first thing that I'm going to do is I'm going to disable the constraint for the clavicle and for the hands. And then we'll re-enable them later and see what we need to do to fix them. So I'm going to go to my left clavicle root auto, which has the constraint on it, and I'm just going to disable it. And because everything is in its default position, nothing changes. So that's fine. And then I'm going to select both the hand bone root and the hand bone offset for our controls. And they have constraints, so I'm going to disable those constraints. And again, everything is in its default position, so nothing changes. And now for the arms, I'm going to take all of these twist bones, and I'm going to ensure that keep position when parenting is turned on. And then I'm going to unparent all of those twist bones. And these twist bones are important because these are the bones that our arm geometry has been weighted to, not these large bones. These large ones are just for structure. So we're going to have to come back and adjust these ones as well in a minute. So now I can move my arm bones. And you'll remember earlier that I mentioned that I just want to move this rotational point just toward the middle of the arm a little bit more. So how can I do that? Well, it's probably not a good idea to just grab these arms and rotate them. First of all, they have IK on them, so that might be a problem. I could use the actual arm controls to rotate them, and then maybe clean the transforms to shove those transformations into the pre-transform, but that's not particularly clean. One thing that we can do, which a lot of people don't even know about, but is super, super handy, is to go back into the Bones tool and make the adjustments using the Bones tool, because the Bones tool helps us by taking care of a lot of little features on the bones in their creation, and we can just treat them as if we're remaking them from scratch, when really we're just adjusting them. So let's see how that works. I think the first thing that I need to do in order to use the Bones tool is to make sure that the bones I want to adjust are selectable. So I'm going to turn on the selectable flag for those two bones. And then in the viewport, I'm going to go down into the Bones tool. And if I turn off this geometry, you'll notice something about all of these bones, that the upper arm and lower arm bone have these little square blue dots at their root and tip, but that none of the other bones do. And that's because none of the other bones are selectable, whereas the lower and upper arm bone are. So what I can do is, as I mouse over this, you'll see I get a little XYZ pop up. That's telling me that I can select and transform this position, which is exactly what I want to do. So I'm going to select this. You can see that I get a handle right away. So I'm going to turn my geometry back on. And now, because this bone is just aligned the way it is, I can simply move it forward. And what that will do is, it will move the position where these two bones meet forward. But because I'm in the Bones tool, it will adjust the lengths of both of these bones. I can show you that just like this. You can see that it's adjusting the lengths perfectly. But there's another thing that I want to keep track of, and that is that I have IK on these bones. So I have a goal here at the wrist, and I also have a twist, which is out here behind the character. And because I'm in the Bones tool and I'm adjusting the bones, and the bones have IK, the Bones tool is going to adjust that IK as well, as if, as I said earlier, as if we were just creating these bones from scratch. So I'm going to turn on my IK controls. So you can see there's that control object that we made, which is the parent of our twist control. And here's the goal for the arm. But I'm actually going to turn on the real object. So here's that IK control and here's that twist control. But they are parents of the actual goal, which is that purple cross, and the twist goal back here, which is this sort of turquoise shaded box. And it's important to have these on because when I adjust the bones that have IK, I want to see what effect that has on these two objects, because these are very important objects for our IK solution. So just to recap before I actually do anything here, I've turned off the constraint for the clavicle and for the hand. I've unparented those twist bones. I've turned on selectability for the bones that I want to adjust. I'm in the bones tool. I've turned on the actual IK goals for the wrist and the twist. And now I can adjust my bone. So as I said, I just want to move it just a little bit forward toward the center. Just, let's say, there. And you'll notice as soon as I let go of the mouse, the bones tool knows that I have IK on these bones. And the default position for the twist goal is to be at the elbow. And that's not what I want. So very carefully, I'm just looking around to make sure that nothing else has changed. And I can see that my wrist goal has stayed exactly where it is, so that's good. So I just need to reposition this twist back to where it's supposed to go. So I can escape out of the bones tool because we've adjusted the bone and we don't need to be in this tool anymore. And then I'm going to go to this twist, which is this guy here. And this is the position that I want my arm bone to twist from. And I can see that my goal object has just snapped back to the elbow. So I can select that object. I can extract its pre-transform. So you can see that it's transformed away from its parent by this amount, and it's reoriented itself to be in line with the bones. So I can simply zero out its rotation and zero out its translate. So now it's back in the position that it's supposed to be. Everything is unchanged, so I haven't accidentally twisted my arm solution. So now I can turn that guy off. Our wrist goal, again, is exactly where it should be. I can turn that off. And now I can figure out what I've broken and try and fix it. So the first thing that I'm going to do is reestablish our constraints. Because right now I can use my transform tool and I can use my arm. But you can see the hand isn't following because it's not constrained anymore. My arm geometry is not deforming because the twist bones aren't following the arm bones anymore. And the clavicle is not doing that subtle little shift that it used to. So I'm going to undo that. I'm going to come up to my left clavicle root auto. I'm going to re-enable the constraint, but I want you to watch just really carefully. It's a subtle little move, but you'll see that this bone just moves a tiny bit. Don't know if you could see that. It's just a small little adjustment. So I'm going to enable the constraint. I'm going to go into the constraint network. And you can see that I have an offset chop, constraint offset. And I'm going to update that offset. So watch again, this bone will just slightly move back to where it's supposed to go. So that's perfect. And then I'm going to do the same down here for the hand bones and hand controls. So if you watch very carefully, this one will be a little more obvious. But if I re-enable this constraint, my hand bone is going to move down. And so I need to go inside to the constraint network. Whoops. And you can see I have an offset constraint object offset here. So I need to update that. So watch again at the wrist. Pops back to where it should be relative to the arm bones. So that one's good. I'll go over here to the controls, re-enable that constraint, and then update this offset. And you didn't see a change there because we weren't showing any of our controls. All right, so all that's left to do is to fix our twist bones. And this is just relatively easy. So we haven't done anything particularly crazy. So the situation that we're in now is that we have an upper arm bone. We have 4 unparented twist bones. But these twist bones are in a particular kind of relationship to each other. They are positioned as if they were parented to each other. So the root of the second bone is at the tip of the first, root of the third is at the tip of the second, and so on. And so we want to maintain that relationship. But we also want the total length of all 4 bones to equal the length of the entire upper bone. So the easiest way to do all of that is to parent these so that they'll remain root to tip. So we can just parent all these together. And now we can take this first bone and we want to orient it. We want it to keep its position here, but orient itself along that bone. And the easiest way to do that, if we untick keep position when parenting, and we unlock our translate, let's see if this works. Doesn't work, or did it? So it went way over here, but we have a bunch of information in our pre-transform. So let's bring that out. Let's get rid of all of that. And that didn't work. I think we shouldn't have done that. Let's keep position when parenting. Parent that to the upper arm bone. So now this bone is in the right position. Let's extract the pre-transform. This is what I did wrong. So now it's in the right position, but its orientation is slightly wrong. Its Z-translate position is the length of the bone. So that's what we want. So I'm just going to zero out its rotation. I'm going to clean that transform and relock the translate. And because it's the parent of these 3 other bones, they will inherit that correct orientation. So now those are all good. But now we want to reparent each of these individually to the upper arm bone, because they have that individual twist going on. There we go. So now we can test this. You can see now the upper arm twist bones are pulling our geometry along. So we just need to fix our lower arm, and we can do that in the same way. Parent them all to each other. Parent the first one to the lower arm bone. Extract its pre-transform to get that rotation. And you can see that it shifted a little bit there, but we'll take care of that in a second. We'll unlock the translate. We'll clean that transform, lock that back up again. Oh, let's do this differently. We got a little bit of a, there we go. So sometimes it's a little fiddly. You just have to understand what you want and then click around until it does the right thing. But you can see something interesting when we reparent all of these twist bones individually to the left arm bone. You can see that it looks like our arm has straightened out. If you compare that to our right arm, our right arm has a little bend to it, but our left arm has straightened out. And the reason for that is that the capture positions of these twist bones have not been adjusted. And we can show that if we go up into our soldier body, and we're going to have to redo our capture anyway, but if we put down a bone capture line SOP, and then we go into our soldier and we look for those twist bones. Accept that. And when we display this, we can see this is where our twist bone capture positions are. But when we go back and look at where our bone's deform pose is, you can see that they're offset. So we need these capture positions to match our deform positions, because that's what's causing that strange stretching, is that they're misaligned. So let's just display that again. So how can we do this? Well, let's turn these off first of all, for now. We can use on the rigging shelf a tool called Align Capture Pose. So this tool does exactly what we need. So with nothing selected, I'm going to click Align Capture Pose. And this has three methods. Match capture pose with deform region, which in this case is exactly what we want. We want to match this capture pose to the deform region. But it also has match bones with capture pose and match deform region with capture pose. So depending on what your needs are, you have those three options. The one you're going to use most is probably match capture pose with deform region. So that's the default. So the status bar will tell us how to use this tool. So we want to select the method from the menu and press Enter to align the currently selected bones. But right now we don't have any selected bones. And then it says, or reselect the bones to be aligned using the current method. So let's test that on our upper twist bones. I'm in the tool. I'm going to select these bones. I'm going to then accept selection. And you can see, if I go to wireframe, you can see that these black lines are representing our capture pose. And that's exactly what we want. So now I can just select the lower arm twist bones, and those pop right to where they should be. So that's great. It's exactly what we want. We can escape out of that tool, can turn our arm bones back on, and now we can check out our deform. You can see that it's still slightly bent, or rather slightly straightened. And that's because we need to recapture with these new capture pose positions. But I can get rid of that. Because this is all procedural, we haven't done anything destructive at all. Even the paint that we did will still come through. So we can just go up past our stash SOP. So here we have our fingers, and then here we have our body, including our new arm positions. We've merged those together just like we did last time. I'm going to recreate our tet mesh to embed those points with the attributes into the tets. Bone capture by harmonic. There we go. And now we display our stash SOP and then restash the input. And now we can remake our head group, remake our jaw group, apply those overrides, even apply the paint. Press deform. And now our arm has that bend back in it, just like the right arm. But you can see the bones are a little more forward than on the right-hand side. And everything is working well. And we can compare. We turn on our right arm controls. Just raise these, whoops. Raise these both up. You can see the difference in the deform. It's not a huge difference. But it's a little bit softer, a little bit more natural. And there we have it. So if you need to do any of these kinds of things, that you've made your rig, you've done a capture, you've even painted some, but then you find that you need to make an adjustment to one of these bones, it's really not, as you've seen, that big a deal. We did have to take into account anything that was related to those bones in terms of their position, and things had constraints on them. But provided we were aware of those things and we took them into account, actually moving the bone and then reestablishing our capture, including any and all work that we've done on our capture, wasn't really a big deal. It was really quite easy. So I hope that example is useful for any other type of example of a bone that you need to adjust in the future. Before I forget, we want to adjust the length of all of these twist bones. So the easiest way to do that is let's just reparent them all to each other, like that. And then we're going to go to the upper arm bone, go to its bone tab, grab its length, just copy that. Go to the first bone of our twist bones, throw that length in there, and then divide it by 4. And now if we click between the expression view and the evaluation view, we can see that we have a new value. And I can copy that and then delete that channel, which will just leave that value. I can come to my 3 other bones, paste that new value in, and now they'll be exactly 1/4 of that upper arm bone length. And then I can reparent them. Then I can do the same here. Take that length into the first bone, divide it by the number of bones, which is 4. Get that value, delete that channel, put that new value into the other 3 bones, and reparent. And there we go. No matter how good your initial capture is going to be, you'll almost always find that you need to go in and make some slight adjustments, just as we did with the head or with the arm. And in order to save time, you don't really want to be doing weight painting or weight editing on one side and then have to do it on the other. So Houdini has a capture mirror tool that we can use to make adjustments to one side of our geometry and transfer that to the other. So to demonstrate that, I'm just going to change the way the weighting is on this foot. If I look at my toe rotation, you can see that it's a little soft, sort of, it's rounding out here, and I want that to be a little bit flatter. So I'm going to use Edit Capture Weights tool, and I'm going to grab these points, that. I'm going to go to absolute mode. Crank those right up to 1. Those points as well. And then I'm going to take these points. I think I'm adding to my selection. I just want these points. Absolute mode. Crank those up to 1. And if I go into my SOP network, I can see I have a new capture override. And I'm going to turn on update point colors. And you'll see that this looks quite soft right now, but if I update the point colors, it'll show the result of the edit that I've made. There we go. So now that's nice and stiff, which isn't really good looking, but for the purposes of demonstrating, it'll show a real difference between the two, between the right foot and the left foot. So when we mirror, we'll see a real difference. So the Capture Mirror tool is used here at the object level. And you can see it's up here on the shelf. So I'm just going to click this shelf button, Mirror Capture Weights. There we go. Now it says select the destination points to mirror capture weights to, and then press Enter to complete. With any kind of character, you're going to have lots of little detail around the origin. So it's actually pretty difficult to, in a viewport, even if you switch to an orthographic view and did a box select like that, it's going to be pretty hard to get exactly half of your character. So what I like to do, just come out of that, what I like to do is do part of the tool here in the viewport and then finish up the tool in the network at the SOP level. And the way that I do that is it wants the destination points. So I just grab a few points on one side and then I'll hit Enter to continue. And now it says select the source bones or muscles to mirror from and then press Enter to continue. And the bones that I want to mirror, I could do just some selected bones. And in this case, the only bones that I've adjusted are the foot bones. But I could do the entire skeleton. In this case, I'm just going to do the foot bones. So I'll select the 2 foot bones and I'll press Enter to continue. And now it says select the destination bones or muscles and press Enter to continue. And the tool will try to guess what the other bones are. So in this case, I have left foot bone 1 and left foot bone 2. So the mirror tool has tried to look for the right-hand side bones, and it has found them. So that's good. I don't have to select these manually. So I can just hit Enter in the viewport. And now we can see that we're still in the Mirror Capture Weights tool, but we've been given this directional handle. And that just is trying to show us what it's done. So I'm going to escape out of the tool. I'm going to go into our geometry level. And we can see that we have a Capture Mirror tool. So what I'm going to do is say foot, just so that I know that in this operator, I'm mirroring these foot bones. Because I might later on have a change to the hand or to the arm or various other things. And I'll want to keep these separate. So let's take a look at what this tool has given us. So we can see in the group parameter, we have some points. And those are the points that I grabbed just in the hand here. But I'm going to replace that in a minute with a group that I'm going to build here at the SOP level, just as I did the head and jaw group. But I'm going to build a group called right-hand side, so that whenever I want to mirror something, I'm always going to mirror from the left to that right-hand side group. And then it says use the group as destination. So depending on which direction you want to go, you could change that. The capture type we're using is bone capture. The behavior is called leave unmirrored captures or copy unmirrored captures or average weights. I tend to leave this almost exclusively on leave unmirrored captures. And what that means is that it's just going to ignore everything else. It's only going to transfer the ones that we specify. And then for the origin, it's basing this on the point selection that we made. But I always zero this out. Just have the origin be the origin. So you know that if you're mirroring from left to right, that it's this XY plane or XZY area that you're mirroring from. And then again, the direction here is 1 in X. So that's the plane. And then we have from and to. This is going to be a string list of capture regions. So you can see that we have quote left underscore foot underscore bone underscore 2 slash C region 0. And then bone 1 is here. And then we have the right-hand side bones here. And we can add to or change these two lists using the drop-downs here. But remember that these are strings. These are not operator paths to the bone. It's actually a string. So that's something to keep in mind. And then again, point coloring says default source color. We're going to color by capture region. So let's make that group. I'm just going to go above the capture mirror foot, and I'm going to put a new group node down. I'm going to call this right side. And the group name is going to be right side. And I'm going to say, turn off base group enable. And I'm going to make a bounding box. Size is going to be 2.1. The center at 1.05. So I know that my character is just over 6 feet tall, so a little over 2 meters is going to be fine. And then the center here is going to be because my size is 1, so my center is going to be right at 0.5. And of course, my group type is going to be points. So now I just want to go in and check that I am getting all of my center points, especially in the mouth area. I want to make sure that you get these center points. So that's all good. Just check the back. Good. So now I have a group that is the right-hand side points of my entire character. So if I ever need to do something going back and forth, I have this group. So I can feed that in. I think that wants to be -1. So now instead of using this point list, I'm going to get rid of that, and I'm going to use right-hand side. So now I'm using this point group as the destination group. And if I look, I can see that I have a nice hard transition here for my right-hand foot. So now we can go up to our deform. We can check to see if the behavior that we've painted in here is evident here. So I'll go to my left toe. That's nice and hard. And the right toe is the same. So you can do all kinds of work on one side of the body, and even in the chest, the torso region, you can make changes and, paint across the center line, but just make sure that one side is pretty much how you want it. And then you can use that mirror tool once to mirror the whole thing from left to right, or you can do it as I've done it on selected bones. So here I've just mirrored the foot, and later I could mirror just the hand, just the shoulder, etc. So that's a pretty handy tool. And again, if you follow the way that I've done it, just invoking the tool in the viewport and giving it stuff like a point selection and quick selections, just so that it sets up this capture mirror SOP for you. And then you can go in and make sure that all of these are exactly what you want. And it works really, really quite well. At this point, our work is pretty much over. We've rigged our character. We've captured his deforming geometry to that skeleton. We've made some adjustments. We've fixed some weighting issues. We've made some specific weighting decisions about how our geometry is going to deform. And then we've mirrored those changes from the left side over to the right side. So what do we do now? We've got our character. He's all colorful, which is probably not what we want. But there are also some things that we might want to do to the geometry itself after the capture. So that's what we'll be talking about now. I'm going to turn off our bones. We've got our twist bones still displayed. And let's go into the geometry here and see what we've got. We've got our Biharmonic capture network up here. We have our stash. Built our groups, did those capture overrides for the head and jaw. Then we built that right-hand side. We mirrored, and now we have our deform. We don't really want any of this stuff hanging around in our network. We certainly don't want to put this into a production scene. But there's also some things we can do, or things that we may need to do for our production. In the case of this soldier, he isn't just this naked guy. He's actually got, I can show this geometry. He's actually got quite a bit of geometry associated with him. So he's got a body, but he also has boots and pants and a jacket and a whole bunch of gear. He's got a backpack and a hat. He's actually got two hats. He's got like a nice hat and then like a helmet hat. So what do we do with all of this stuff? Well, it's a little outside of this tutorial, but we can talk about maybe pants and his little tank top. So let's give him these things. And we'll add those into this existing capture network. But it may be a lot of work to capture these individually. And it may be difficult or even impossible to capture them together. And so right now we're going to explore something called attribute transfer. And with that, we can take some geometry that has, I'll put this over here, has our capture attributes. And we can transfer those attributes to some new piece of geometry that doesn't have the attributes. Then we can combine those into the deform. So in that way, we can add this tank top and the pants and even some of that other geometry without having to capture it manually. So let's see how that's done. So we'll start with our pants. And we'll put down an attribute transfer. And this SOP allows us to transfer detail, primitive, point, and vertice attributes. So I'm going to turn all of these on for now. The first input here is geometry to transfer attributes to. So that'll be our pants. The second one is geometry to transfer attributes from. So that will be the result of our mirrored foot capture. So that's our entire soldier, all his capture attributes. So now I'm going to display the attribute transfer. With these fields empty, this means everything. So find all the detail attributes, all the primitive attributes, etc., and transfer them from this geometry to this geometry. But I don't necessarily want that. So let's go through and see what attributes are being transferred. So in the detail, I do want to transfer the capture frame and the skeleton root. So I'm going to make that an explicit list. For my primitives, I only have a name attribute. I don't need to transfer that, so I'm going to turn that off. Point attributes, I have color, position, bone capture, and p-capped alpha. This p-capped alpha is, let's do this over here so you can see that fully. P-capped alpha. That's the result of the paint that we had. The capture layer paint tool, when you paint a stroke, it also paints the alpha of that stroke. So that's why that attribute exists. And we want to keep that around as well. So I'm going to say color, bone capture, and p-capped alpha. And then vertices, we're not going to transfer the normal. We'll just leave it like that. So we'll turn off vertice. So now I've transferred those attributes. And you can see, because we transferred color, you can see that it worked really, really well. The color that we have on our legs here has been transferred to our pants. But you'll also notice that it's a little bit crunchy. And part of that is because of the resolution between the two pieces of geometry. If we look at our leg here, you can see that this black wireframe is our leg, and this color wireframe is our pants. And there's plenty more geometry in our pants than in our leg. So when we transfer a point attribute here, we're transferring it to lots of points. So the resolution difference is really not helpful. But something that we can do to improve that, so we can just put a subdivide and we can subdivide, and turn that off. We can subdivide our original skin. And any attributes that are on those points will interpolate. So now we're transferring from a higher resolution skin to the high resolution pants. When we do that. And you can see that that is smoothing out that transfer. In fact, we can go up a little higher. So now that's quite smooth. And we can test if this works just by plugging in our deform. We'll turn on our deform, and I'm going to go over to my parameter pane and just raise this leg up a little bit. So you can see that it works. We've transferred the capture attributes from our body onto our pants. But it's pretty crunchy in some areas. So how can we improve that? On the attribute transfer, on the conditions tab, there's a max sample count parameter. And if we increase that, we'll see a definite improvement. So let's go up to 10. So that's a lot better already. Still a little crunchy. Let's go up to 30. Even better. Say 40. See what happens. There we go. So it's not going to be perfect. There are going to be areas you can see here that don't transfer very well. But doing the work here to fix this is pretty minor compared to the work of capturing and fixing this entire leg on both sides. So that's saved us a huge amount of work. So let's put that back. So now we've done our pants. Let's take, we can Alt drag, create a new attribute transfer. Let's put in our tank top. See how that looks. So that looks pretty good. Again, we're using the same max sample count of 40. We can plug that into our deform and just bend him over a little bit. So that's pretty good. It's not too bad at all. So let's use our merge. So we're going to bring in the result of that attribute transfer of the tank top and the result of the attribute transfer from the pants. And we're going to combine that with our original unsubdivided body. So we have that. And this we can feed into our deform. And there we go. So again, it's not 100% perfect, but fixing that little interpenetration, that little guy there, doing that kind of fix is going to be pretty fast. And we haven't had to do any other work anywhere else on the tank top. Whoa. And our leg is really good. We're getting really nice deformation all through that knee. And this, again, this little area to fix is a couple minutes work. But overall, that's a really good result. Of course, we don't want to leave any of this live because it's really quite slow. We've got this a subdivide in here with a depth of 2. So this is a massive amount of geometry that we're transferring attributes to and from. So I'm going to set this back to default. So how do we deal with all of this? Well, we want something light and fast into our deform. And what I recommend is just put a null down. There's a few ways that you can do this. The first thing we want to do is actually delete that color attribute. We may not ever want to see that again. So we can just delete that. So now we have our geometry, and we'll want to look at all of its attributes. It's got all these groups. We don't need these. So we can do group delete. So we've gotten rid of all those unnecessary groups. We've got that, where is it? Name attribute, we don't need that. So we need bone capture, we need the pcapped alpha, and we need pcap frame and pcap skull root. So as far as our capture attributes go, these are the ones that we need. So we'll feed that into this null. If we have other things to do, if there are other things that we want to work on for our character, but we don't want to constantly have to be recooking all of this stuff that we've done, we can do something slightly similar to the stash node. Well, for one, we could use a stash. So we can plunk a stash in there, stash the input. And now our deform is going to be quite quick. I can go back up and So that's nice and fast because we've stashed that input. So all of this work that we've done is now contained in this one node. And so our deform can just do its work. But we wouldn't really want to pass this down through production. And we certainly wouldn't want to lock a node. Like doing this, if we hold Control, we can lock this node. And that's effectively the same as using a stash. It's not quite as versatile because the null doesn't have a little button like the stash does. So it's harder to update. But both of these are things that I wouldn't recommend unless you know that you're going to do more work. Then it's very, very convenient, especially to use a stash node, get rid of that, to just put a little brick wall between all of this work and any new work that I want to do here. But when I put this into production, I don't want to use a stash node. I don't want to use a locked node. I want to use just a file in like we had way up here at the top. And if we look at our type properties, we go to the extra files, should be down here at the bottom, I have a soldier geo, and that's the soldier's entire body. So what I would probably want to do is either replace that or just append to it. So I'm going to take this null, and I'm going to save this geometry. And in the file dialog, I can go to opdef. I can go to object, because our soldier is an object, HDA. Come all the way down. So here's my soldier. And here are all those bits of proxy geometry. And there's that soldier geo. So I'm going to select that, and I'm going to rename it capture. So I have soldier geo capture.bgeo. I'm going to accept that, and I'm going to accept that. And now I can take that file sop and just change this to capture. And so now I have the result of all of this work, but it's saved as a single piece of geometry that's inside my asset. And so at this point, this is what I would want to pass down to an animator. Because an animator doesn't need any of this stuff. And you'll remember at the very beginning of this series, I talked about how I have this display switch, which is going between a null for our proxy and a null for deform, and then an out node. And what I could do is take my soldier geo capture that I've saved, pop that into the deform, and now display that. And this is a nice little network that's well organized. I have a switch for when I go from geometry off, geometry proxy, geometry deform. I have an out node that I can reference elsewhere if I want my undeformed geometry. And then I have a deform node that will deform my character. And then what I could do is I'll save this HIP file as a working file. And then when I save out my asset, I can grab all of that stuff and just delete it. Then I can save my asset, and it will just have this efficient little network in it. Another thing you might want to do is to have some sort of LOD system here in the SOP level. So in addition to having proxy option and a deform option, your deform option could, it could have another switch up here that was feeding some different LODs. So we could use a polyreduce to feed in our geometry that has capture attributes. And we could go down pretty low. Let's try, go down to 10%. He doesn't look like much. But if your character was way over here, it would certainly be just fine. And we can test to see what that looks like when it deforms just by plugging that polyreduce into the deform SOP. If I lift that left leg up a little bit, it's pretty hard to tell that that character is 10%. It's gone from 39,000 points down to 2,200 points. Let's try 5%, see what happens. Right, so now we're at just over 1,000 points. And if he were textured, you'd have a pretty tough time determining what resolution he was at. So that's something you could also incorporate into this SOP network. You may not want to do live polyreduces like this. You might want to save out the result of these, just as we did with our capture geo. But you could have a series of them. So you'd have that one at, let's say, 20%, and this one at 50. And you could throw these into a switch. And that. So you could have your original resolution as the first option, and then you could have different resolutions, and you could promote this input up to your parameters of your soldier, so that depending on the needs of your scene, you could switch between different LODs. And the polyreduce will preserve those capture attributes. And it really does a pretty nice job. You could have something like this going on. So those are some other options. That's going to conclude this second rigging series in Houdini. I hope you found it informative. Hope it helps you get your characters rigged and ready for animation. If you have any questions or comments, please let us know in the forums. And stay tuned for more tutorials on rigging. Thank you.